Introducing the team of engineers who built this fabulous machine.
Griffin Shovel,
Josiah, Joseph, Wilbur Akea,
Ali Rahal.
Dylan Thomas,
Elazar Tonev,
Ravi Patel.
Introducing the team of engineers who will now explain the cycle.
So the internal combustion engine model that we built is based off an air standard Otto cycle. And the first process to the second process is isentropic compression, meaning change of S is equal to 0. And here it is on the PV and TS diagram.
Yep, and here we're showing it in more of a combustion engine focused diagram where the piston is going up in order to show compression of the gases which float in through the inlet valve.
And 2 to 3 is constant volume heat addition with work equal to 0. And again, here it is on the PV TS diagram.
Yep. And here we have the heat addition here, which is a little bit more drastic in our case, which is really just a combustion of all the gases in here, provided by the spark plug.
And process 3 to 4 is isentropic expression again on the PV and TS diagram.
Yep. So here, it's also in this diagram, but basically what's happening is there's a combustion happening here, so rapid expansion of gas, which pushes the cylinder down, which is basically just the isentropic expansion of the system.
The final process is 4 to 1 constant volume heat rejection.
So for this process, it's a little bit more ideal. It doesn't really happen all that often, but basically what happens is before this piston goes up, trying to relate it to that diagram, some heat is rejected along with the gas. And basically to loop this entire cycle together, this will push up and push all the exhaust out, and then it will start over from here, which will come down and fill all the exhaust in with the inlet stroke.
Introducing the fine engineers who built the machine. So what we learned while building this fabulous machine is the inner workings of a combustion engine. We put apart the pistons, we built the lights, we put all the screws that were really tiny and hard with a screwdriver, but it all worked in the end. Now my friend Griffin will explain the design aspects.
So, what was really cool about working with this project was when we were assembling each little part, we got to observe why things fit together from a design standpoint. So, in the real world, we're not just putting numbers in using charts to calculate the necessary values to solve these problems. We actually have to design some of these systems. So to be able to see, oh my gosh, a piston looks like this, it's going to fit in like this, the motor is going to drive it around, and then through the Otto cycle, you're going to be able to get an output using the energy to create whatever desired motion or energy output you want. So it was really cool just not doing homework problems. So I like that a lot.
In addition, plugging into charts and looking at equations, it's really easy to lose sight of what's actually going on. So by completing this model, we were able to see the compression, the expansion, how the combustion would actually happen and how all the parts lined up and would work together. So not just a model for the cycle, but how it actually all gets put together. In addition, we talk a lot about inefficiencies with certain cycles, and it was cool to see how that could actually be integrated into this model. We could lose mechanical energy through inefficiencies in how the shafts lined up, and through all the sort of things that it has to power on its own. So we're gonna go ahead and start it up so you can see.
So we're gonna power up the machine and show its
power.
Introducing the fabulous engineers who modified our awesome project.
Alright, so one of our tasks was to improve the combustion engine. So we decided to do that by adding an alternator, which would make it a little bit more realistic. Robbie will get into that in a second, as well as a turbocharger, which Wilbur and I will explain shortly after, and how we believe it improved the entire model.
So first off, we have the alternator. The alternator generates electricity for the battery and repowers it in order to drive the car's electrical systems. It gets its power from a pulley represented here by the string, and that's driven by the motor, and then the motor turns the alternator to generate electricity.
And now we'll kind of get into the turbocharger, which is located on the side. So a turbocharger is made up of two components, a turbine and a air compressor. So what happens is the exhaust gases that are released, as explained in the previous diagrams, are pressed or forced into the turbine, and then the turbine causes the air compressor to run, which forces more air back into the motor, and now we will explain what that does for the engine.
Alrighty, so now the whole purpose of pushing air back into the motor is so that more air is mixed in with the fuel, thus burning more fuel per second and giving more power for the engine. That way the car can run much better. So this is how we believe we made the engine more realistic and much more practical in the real world.